Welcome to Earth Science. Today what I want to do is, like I said, get a little closer to the surface with what's going on in this inferred properties of Earth's interior. This reference table does not do a very good job of really accurately, yes, but clearly no, showing us what's going on in this reference table. So if I were to like zoom in and do like a little box right here and say, let's take this little section right here between my fingers and blow it up so that we can get a little bit better definition. That's what we'll do over here. And then I'll scan this and throw it in the Google Classroom. So, if this is the surface of the Earth, I'm just arbitrarily dividing it in half so we can see what's going on. Up here would be the atmosphere, or surface, represented by that green line. First thing we're going to deal with is what we walk around on, called the crust. So, over here on the left is going to be, I'm going to have a heck of a time doing this with one hand. Over here on the left is going to be that difference, that we have crust, and then below that we have mantle. And that's really it. Like if we went way down deep, we could get down to the cores, but we're not going to worry about that in this diagram. Just crust and mantle. So this left side is going to be how it's represented by basically the stuff that makes it up, like its chemical composition will be how we define this difference over here. So this is... I'll write that over here. Based on composition. I don't even spell it right. Over here on the right, what we're going to do is say, well, that's great, but what really matters, like when it comes to tectonics, is the behavior. So that's what I'll write over here, is based on behavior. I don't know if that's the best word to use, but we're going to use it. So how do these things like actually act? When we talk about this thing like tectonic plates, what are we really talking over here? It's unfortunately more complicated than this, because what moves is a thicker chunk than the crust. And what it is the lithosphere. And then below that, the upper part of the mantle, which actually does show up on this pretty well, is the asthenosphere, plastic mantle. In this case, plastic refers to the ability to flow. Still behaves as a solid, but a solid that flows under pressure. Silly putty, Play-Doh, something like that. Think of it as a very, very rigid Play-Doh. It slowly morphs. So that's what's going on down here. Asthenosphere, however you want to say it. And then if we want, yes, the cores are still way down here. You can eventually get down to stiffer mantle, just where it hardens up a bit more, flows a little less. Not really going to be concerned about that today, though. Oh, and I spelled it wrong. I'm trying to talk and spell at the same time. Because here's where the rubber meets the road. This is talking tectonics. The lithosphere is the thing that moves, and it's composed of two things. It's composed of the crust and the rigid upper mantle. Because remember, from here down is all mantle. You got the rigid upper mantle stuck in the bottom of the crust for the lithosphere. You've got the plastic mantle, or the asthenosphere, through here, and then you've got the stiffer mantle down here. And then again, way down would be the core, and we're not going to worry about that today. So when a tectonic plate moves, we're talking lithosphere moving. So the question that I always ask, and I don't think I'll answer it in this video, maybe I'll figure out a way for you to answer it. When somebody that knows their geology sees the term crustal plates, they don't like that. It's not accurate. Why is the term crustal plates frustrating to a geologist? That'll be the question. All right. Now, to be mentioned is the New York State Regents, which you guys don't have to take, congratulations, is going to still tell you that this asthenosphere moving, going through convection, which hopefully we all remember, convection cells, is the reason why that lithosphere moves. More recent science has revealed that that's not really the case. It has more to do with the weight of subduction, and now we haven't done subduction zones and all of this yet. We're going to do that. Mid-Atlantic ridges, we got to deal with that. the weight and the gravity pulling these things is reasonably really most likely what was the lithosphere. Now, the asthenosphere underneath it, going through convection, can that help? Yeah, for sure. And if it weren't kind of plastic, then the lithosphere wouldn't be moving. You know, if it was hard, it'd be solid. No motion, no plate tectonics. But as a driving force, it's not really the case, even though it's still stuck in our state curriculum. It's a funny transition from, understood science, new discoveries, working their way through like a legislative body, making its way into a state curriculum. That's really slow. So, but at the end of the day, since you guys aren't taking the regents, that bit of confusion won't show up. So yeah, let's probably wrap it up there. We'll maybe say that this is also not a great word to use. This will be the crunchy. This is like the Skittle model of the planet. You have to ignore the core because there's no core in a Skittle. But you got this crunchy outside, and then this chewy inside. It's not a bad comparison. The crust itself, I mean, it's crazy thin. We live on it. We're confident. We walk around on it, right? But if you were to cut an apple in half and look at the apple from the side, the crust and the skin of that apple are about the same proportion to the crust to the size of the Earth. It's scary thin. And then we'll just keep in mind that this lithosphere is really the thing that moves. You might see MOHO right there. That's a shortened name for the Mohorovic discontinuity, which you don't have to know, don't worry about it, but that's the line between crust and mantle, a guy discovered by studying seismic waves. So that line is there, but really this whole thing like acts, like behaves as one rigid body. So chemically, crust, mantle, core. Behavior-wise, lithosphere, made up of crust and rigid upper mantle. Asthenosphere, which can flow. I'll draw some convection cells in here. I'll finish those off screen. And stiffer mantle down there. 7 minutes. Thanks for sticking with me. Welcome to Air Science.